Hi everyone, welcome to today's topic. So this is my topic number 15, and for topic number 15 I have chosen kinetics of enzyme catalyzed reaction. So enzyme catalysis is a very important part from chemical kinetics, and which is from physical chemistry obviously. And in this chapter, actually from various graphs of enzyme catalyzed reaction and equations, many questions are actually asked, and so you should not avoid this chapter. And also I want to tell you that previously I have uploaded uh, 2 to 3 videos on chemical kinetics. One was from the basics of chemical kinetics and zeroth order, first order reaction, and also second order reaction. And another video I have uploaded just a few topics before that, the Arrhenius theory. Okay, so these all are actually very important. So you should not avoid these chapters. So if you have not watched this video, please watch that videos, those videos first, and then come to this video. That will be helpful for your understanding purpose. So let's start with today's topics. It will be very helpful, and keep practicing with me so that you have to because learning is not enough. Practicing is very important to attempt more question in less amount of time. So that's why the practicing of PYQs and other questions from various books is very much important. So I have incorporated many types of questions which are actually can be asked. So I have shown you that, and this is your responsibility. After knowing every kind of question, you have to practice more. Okay, so please watch it first, and I hope you will be you will be interested after watching this video. Okay. So first, enzyme catalysis. So we have to understand that what is a catalyst. Okay. So first we will understood that what is catalyst and enzyme. We know actually, but yes. So we have to have idea about this both. Okay. So catalyst is there are few important points about catalyst which I have incorporated here. See, the substance which can alter the rate of reaction. Fine, this can alter the rate of reaction. Okay, it will not participate in the reaction. It is not like that it will participate in the reaction and then reaction rate will be improved. Nothing like that is happening. It is actually remained unchanged after the reaction. So these are some important points about the catalyst. So it can alter the rate of reaction, but how? How? It is a question. So the answer can be simple, that we know that if this is the energy profile diagram for a reaction for a specific kind of pathway. Okay, so this is called actually activation energy. I have previously told you when I was teaching you the Arrhenius theory. So in that video you will find that what is activation energy and what is threshold energy. Okay, so this is the activation energy, when the amount of energy which is needed to for the reactant to convert into the product. Okay, so this is the extra energy which is needed for the reactant. Okay, this is the transition state, we know. So now how it affects actually? So catalyst actually it affects the reaction rate by providing a alternative pathway for the reaction. Okay, which mainly has effect on the activation energy. It gives the alternative pathway, that is fine, but how it can increase the rate of reaction? It can actually alter the has a effect on the activation energy. So in the next slide we will understand it in a better way. Okay, so this is the energy and reaction coordinate. So first again the same thing which was in the previous slide, the energy profile diagram. So this is the A. Now this red color graph, this red color energy profile diagram, let's say it is after adding catalyst. Okay, fine. So after adding catalyst, what is happening? Pathway is different. So which affects the activation energy. See, the reactant and the TS has this much gap now. So EA dash will be the now activation, new activation energy. And it is obvious from the picture also, EA dash is less than EA. Okay, and we know that reaction rate, okay, so we know that activation energy rate is actually inversely proportional to activation energy, or I will say write just EU. Okay, so if activation energy is more, that means more energy is needed to occur this reaction. Okay, to happen the reaction. So then rate will be slower. Okay, so inversely proportional. So that means when catalyst is added, it actually decreases the activation energy, which leads to the increase of reaction rate, or reaction will now happen in a faster rate. Okay, so catalyst lowering the of activation energy, rate constant increases. Okay, no, how we see that this energy gap is low, so small energy is it, but how it actually affects? So if you watch or if you know the Arrhenius theory, we know that K is equal to e to the power minus EA by RT, right? So from where we have the relation of K and EA. So it is lowering the activation energy, which means how K actually K is actually relating with activation energy. If we decrease the value of A, okay, that means so EA is decreasing. That means EA by RT value will decrease. Obviously, this is decreasing, right? Now the minus A by RT will increase. Now e to the power minus A by RT, it will also increase. That means K value will increase. Fine. So when EA are in decreasing order or EA decreases, that time we found that K value is increasing or rate constant is increasing. Okay. And how the rate constant actually affects the rate? So we know that rate constant into some concentration of reactant to the power order, we know. So X is, let's say, the order of the reaction. So rate is proportional to the rate constant, right? So now we got that how when the catalyst, after addition of catalyst, lowering of activation energy happens, that time rate constant actually increases, and when rate constant increases, overall rate of reaction will increase. Fine, we have understood the effect of catalyst now. So now why we are reading this? Because some of you must be thinking that we should know only the we should have to read only the equations and the graphs, so we can solve the questions. But not this is not like the this will not helpful for all of the questions which are asked in CSI and NET, because some questions are related to the basic knowledge. So you have to have the idea, so why we are reading this, how this actually came. So these ideas actually are very much helpful to solve the questions also. And if you are reading, so you should know that how this came and what are the things you are reading. So you have to have the basic knowledges. Okay, so you have understood this. Now enzyme catalysis, we have come to this part. So enzymes are biocatalysts which we have in our body. So in our body we know that various biochemical reactions are going on, and enzymes are in our body. Enzymes are the acting as the catalyst or biocatalyst. Okay, so now we are focusing on the mechanism of enzyme, how it actually affects the biochemical reactions. So many scientists are actually they were working on it, and one mechanism of enzyme which are mainly important and which can explain some of the biochemical reaction rates. So uh, so these actually given by Michaelis and Menten. So this is called Michaelis-Menten mechanism. So this is very important. Now we have highlighted this topic and we have to read it. So they have said that first enzyme and substrate, when we are adding substrate, obviously in a reaction substrate is obviously we need, and when we are adding enzyme or enzyme is in the medium, first they will form, in a reversible reaction will happen and enzyme substrate complex will form. Okay, so in the biochemistry portion also we have seen that enzymes have some active sites in it. Let's say this is the enzyme and it has some, like this way, active sites are there, and there is a matching of shape matching is occurring here, and a particular kind of substrate of a particular shape can attach with it, this enzyme. These are specific, okay, substrate specific. So that is the thing there. So this is actually a reversible reaction, and this by this reversible reaction enzyme and substrate complex will form, okay, like this way. Okay, this is the substrate, this is the enzyme and substrate, and which is not very much stable. Okay, so this is actually from these non-bonding interactions, like supramolecular interactions are going on here, because we know that enzymes are nothing but the peptide chains, consist of many proteins and peptide chains. So here actually the substrate specific part actually came from the interaction between the substrate and enzyme, okay, the various supramolecular interaction. So with that actually enzyme substrate complex is formed, and after that, as it is not very much stable, because ionic interactions or ionic bond, this is nothing like bond, right? This is actually the interaction. So it will again lead to the formation of product, and enzyme will remain same. Okay, like the catalyst. That's why. So enzyme is a catalyst, right? So the properties of catalyst will be in the enzymes also. Fine. So it will lead to the product formation and enzyme will remain the same. This is the actually simple kind of, we can say the simple form of Michaelis-Menten mechanism of enzyme catalysis. Okay. Now we have to have the idea about the enzyme catalysis, the kinetics of enzyme catalysis reaction. Okay. So for that we have to know about the rate constant, and we have to the rate law equation we have to find out, right? Rate equal to k into substrate to the power some order. We have to find out that. So that's why we have actually here the steps. We have just differentiate the steps. E plus S, it will form ES. This is the forward step, and in the backward step, ES will form the E plus S again. See, this is the backward step, and K inverse is the rate constant here. And after that, this step. So 1, 2, 3 steps are there. If you just look into in a clear manner. So third step is ES is forming product and enzyme. Fine. So we have to right now just derive the how this actually uh, the derivation of actually the rate of reaction. Fine. So these are the steps involved. Now what we can do? We can do now that ES is the intermediate. This third bracket is for this is the intermediate forming, and it is not very much stable. So we could not isolate it also. So this is forming and breaking. So by applying steady state approximation, by applying steady state approximation to ES, which we get, what we get. So if you know the steady state approximation, that will be very much helpful to you. But if you don't know, I will just write it down here just for your knowledge. So in the steady state approximation, when we take that, what is happen? So which intermediates are not stable, or in the reaction course, which intermediates are formed in the steady state approximation, what we take? that the formation of the intermediate formation rate of the, let's say here ES will be equal to the breaking. Okay, breaking or disappearance we can write. Okay, breaking, not breaking. So we have to use a good word. So disappearance of ES. Fine. So from when we take a steady state approximation, so we have to find out that what are the intermediates are forming in the reaction course, and we have to equalize the two rates, the formation of the intermediate and the disappearance of the intermediate. That two will be equal. Okay, in the steady state approximation we take that. So we have to find out now the formation rate of ES. Okay, so the formation rate of formation. Okay, so rate of formation we have read it in the starting part of chemical kinetics. So it is dES by dt, positive because it is forming, right? So it will be here, see, this is forming. So K1 rate will be K1 into, for this step, this is, we have to take this as elementary step. So it will be equal to K1 into the substrate concentrations. This is not overall rate. This is for this elementary step. Okay. Is there any other steps where ES is forming? See here, only three steps are there. Here ES is breaking, and here ES is breaking. So only in this step one, actually ES is formed. Fine. This is, let's say, 1, and rate of disappearance, let's say this, equal to, it will be minus dES by dt, right? Because the concentration of ES is decreasing now. So K inverse, it will be K inverse into reactant. Reactant is ES here. And these all are elementary steps. And plus, here also it is disappearing. So K2 into ES, fine. This will be 2. And according to steady state approximation, we have to equalize this 1 and 2. So just write by taking the SSA, steady state approximation. Now what will be K1 ES will be equal to K inverse ES and plus K2 ES. Fine. So why we are interested about the, okay, now in from this reaction, from this equation, we have to solve this equation and find out the concentration of ES, the expression of concentration of ES. Why? Because see, the rate of reaction, this is actually the rate of reaction, K2 into ES, because product is forming here, and this is the actually slow state. So rate of the overall rate of the reaction, I should write it in upside. Okay, just remove this part, and overall rate of reaction will be R, or rate overall for this three. Overall rate of reaction will be K2 into ES. But ES concentration we don't know, because this is an intermediate and we can't isolate it also. So we have to convert this concentration into the other terms, like E enzyme concentration. We are giving enzyme, let's say we are performing a reaction, right? So enzyme also we are giving, substrate also we are giving. So these values we know. So we have to actually convert the ES term with the expression of ES should be put on this form, these concentration forms. Okay, fine. So this is our main equation. This is 1, this is 2. Fine. And another important thing is there, let's say E0. Okay. E0. E0 is initial concentration of enzyme or the concentration of enzyme which we actually add, which we know. So it will be equal to Es plus E, which means Es means this much is reacted, this much E is reacted and form the Es substrate, and this much is left, E is left. Obviously, this will be equal to this. Now we have to put the Es value. Sorry, we have to put this E value here. Yes. Yes. So from where we can write E will be, okay, I am removing that part also because you have understood this till this. Okay. So if I clear it, then you can see it in a better way. So ES, sorry, from here I am just taking the E value. What is the E value? E value will be E0, the known concentration, minus Es, which expression we need to find out, and E will be, if why we are taking putting this value here, because here if in the equation this E is there, we don't know the concentration of E. So we are now targeting the rate, and which is depends on Es, and we have to find out one Es expression so that the terms which are involved in the Es expression, that is known quantity, means it has the terms which are actually known to us. So that's why we have to remove E from here. That's why we are putting this E value, E0 minus Es, this E value here. Okay. So K1, after putting the value, what will be the concentration of, what will be the expression? E0 minus Es, and here S is multiplied, will be equal to K inverse Es and plus K2 into Es. Fine. Now the Es term we have to keep in one side. Okay. So it will be K1 into E0 minus K1 into Es multiplied by S. So just multiply it. Here is also S. Okay. Fine. Will be equal to, again same thing, same. Now Es concentration we have to keep in the same side. Okay. And I am taking left hand side as this. So it will be K inverse Es plus K2 Es, okay, and plus K here K1 was there, right? Yes. K1 Es into S will be equal to what? Will be equal to K1 E0 and S. Fine. Now what will be the Es from here? Just multiplication and the divide. If we divide these all value, if we take here common, let's say Es we take common, that time what will happen? Okay, I'm here. I'm writing K inverse we need to go the next slide. Okay, so here what was the things here? So if we take the Es as common, then K1 into what was there? This term, right? This term. So K1 into S, K1 into S plus, see, plus what will be? K inverse and K2. So it will be K inverse plus K2 will be equal to what? K1 E0S. This one K1 E0S. So it will be equal to K1 E0 and S. Fine. So ES concentration will be from here K1 E0 S by K1 into S plus K inverse plus K2. Fine. So we got the value, right? So now overall rate was what? Rate was K2 into ES. So now we have the rate equation. Rate equal to K2 into K1 E0 S by K1 S plus K inverse plus K. Now for simplification, and we have the one important term here, we should actually derive that term also. So for that we are dividing the both upside and the downside. The all terms are divided by K1. So here if we divide it with K1 only, K2 will be there, K2 E0 and S. Fine. And here what will be the case? Will be K inverse plus K2 by K1. We have divided, right? And here see K1 term is there, so it will be just S. So K1 will be cut, and we can just write S. Okay. Now this K inverse plus K2 by Km is actually, we can take as, sorry, K inverse K2 by K1 is, we can equalize with Km, which is Michaelis Menten constant. So this is also a very important term for enzyme catalysis reaction through Michaelis Menten mechanism. Okay. So just to convert the rate expression towards the with the Km value also, means in the rate expression Km value should be also there, because it is an important part of Michaelis Menten equation. That's why we have divided with K1. And now if you see, this is only Km, so now we can put the value of Km here, or we take this value as Km and write the whole equation now, E0 and S. Now this we got, this is the rate R. Now another modification we can do, which is the K2 E0 is the R max value. Okay, because when we take R max means the maximum amount of rate. So we know rate is, let's see here I am writing, rate is K2 into ES, and we know what we know, E is equal to E0 minus E, which is left actually, right? This much of enzyme have not reacted. So for getting the highest rate, if all enzymes should react, that means E will be now 0. So all enzyme when reacted, E0 will be ES. Obviously, E0 will be ES. That time we can get the R max value. If all enzymes are reacted, that time R max will be, so K2ES, if we put the value of ES there, that will be K2 into E0. So from that we can write R max is K2 into E0, which I have written here also, if you see. So I want you to know or understand every part of it. That's why I am deriving this equation, like, which is taking much time, but I am putting that effort for you only. Okay. So K2 E0 term is there. We can write here R max into S and Km plus S. These two R max and Km value is very important for a enzyme catalysis reaction, and we have converted, we have the now rate equation, and in the expression R max and Km values are there. So these two expression you should remember. Okay. So the rate is K2E0S by Km into S, or which is equal to Rmax S by Km into S. So Rmax is K2 into E0 and Km is K inverse plus K2 by K1. So these three expression you should remember, this one, this Rmax value and Km value. Okay, fine. Now Michaelis Menten constant, which is very important, and in the question only this value can be written. We have to let's say we have to calculate one value from here. So from this is a very important term. So unit of km, how can we define the km unit? Okay, so for that we have to understand that we know that from the chemical kinetics day 1 I am telling you that the unit of rate constant actually depends on the order of reaction. Okay, it is not like that for other terms that like energy, it is calorie or joule. Okay, this is not like that. It is depending on the order of the reaction. So we have to know the this all rate constant. This is not a rate constant, these are rate constants. So we have to understand that this is the rate constant of which order reaction. Okay, so K1 is second order. How we can say that? Because if we take this one, ES plus S is giving ES for elementary step. Okay, for elementary that is step only, this first step, this E and S, the both concentration are involved in this reaction. So we can say this K1 for this particular step, this elementary, this will be equal to the second order reaction. The both concentration are involved here, and K inverse, when backward case, in the backward case if you see, it is only depending on this concentration. Enzymes are substrate complex. So it is first order, one concentration is involved, and again this third step will be also the first order reaction. And for the second order reaction, for the first order reaction, we know the rate constant will be. So overall rate constant, the unit of rate constant was what? Concentration to the power 1 minus n and time inverse, where n is the order of the reaction. So for the first order reaction, the n will be 1, so concentration term will be 0. So for the first order, so let's say K1 and, sorry, not K1, K inverse 1 and K2, the unit of rate constant of these two will be time inverse, or second inverse, we can say minute inverse, hour inverse, like that. And for second order reaction, is K1, second order reaction, it will be concentration to the power 1 minus 2 and time inverse, which will be again concentration, let's say m we can write, or mole per liter. So it will be mole inverse, this will be minus 1, right? Minus 1 to the power minus 1. So mole inverse, mole per liter, so it will be liter only, liter to the power 1 and time inverse. Okay, so from that if we just put the all values here, so Km equal to, we are putting just unit, we have to have the idea about the unit. So K inverse and K2 both are time inverse, so we can write these are the addition. So the same term actually can be add same unit terms, and K1 unit is concentration to the power minus 1 and time inverse, both inverse. Okay, so time inverse will be gone, and concentration inverse was below. Okay, so Km unit will be concentration only. Fine, this is also very important, you have to keep that in your mind. Okay, now the turnover number, this is also a very important term when we have to have the idea about enzyme catalyzed reaction. These are some important terms in the enzyme catalyzed reaction. It is the maximum number of molecules of a substrate converted to the product per unit time. Sometimes it is written the turnover frequency or number. it is said that for the frequency, time is actually we are taking inverse or divided. We divide the time, but generally it is for the turnover number also. If you see the maximum number of molecules of substrate converted to product, the maximum amount of substrate converted to product per unit time, which is actually equal to K2, the rate constant of the this step. Okay, the last step. So this you have to remember. The straightforward question that what is the turnover number for this case? Some values are given. Okay, so you have to have the idea about what is the turnover number which is equal to K2. Okay, and catalytic efficiency. This is also a very important term here, and it is equal to K2 by Km, Michaelis-Menten constant. So many the many terms, the value of many terms can be given, and you have to asked. You are asked. You can be asked that what is the catalytic efficiency of the reaction. So if you know this, that it is equal to K2 by Km, you can answer this in just within 1 minute, let's say. Okay, so you have to this idea. Now the plots, this is very important. Okay, so see it carefully. Plots of Michaelis-Menten equation. So we know this is the equation. So case 1, first we are taking Michaelis-Menten plot, and case 1 is ACE is very low. Okay, ACE is very low, fine. How it affects in the reaction rate? So as ACE is very low, means, okay, just Km plus S, as it is very low, we can neglect that and we can write Km plus S equal to Km only. Now how rate will affect? If we put the value here, rate will be equal to R max into S by Km, sorry, plus, right? This was not plus, right? Not plus. Okay, this will be the rate equation for this case when AC is very low. Now if we want to plot it, so how this is rate versus S, so we can compare with what equation? This is y equal to mx, right? X is S, rate is y, and the slope will be what? M is the slope, and M will be R max by Km. Fine. So what will it look like? Y equal to mx means it will from the origin, straight line from the origin. So it will be like this. Okay, and it is a positive slope. After that, case 2 is when AC is very high. When AC is very high, the opposite thing can happen, which means Km plus S. S is very high, so we can neglect Km here. So we can write that this is S. So how it affects actually? When you put the value in rate, the actual rate equation here, if we put the value, it will be R max into S by what? By S, and we can cut it. Now rate will be equal to R max. So if you see here, there is no S term or substrate concentration term is here. That means when S concentration will be very high, that time the rate will be constant, and it will be, because it is constant, right? We know R max equal to K2 into E0. E0 is constant quantity, K2 is obviously constant. So this will be this will not depend in this plot. When S is high, this plot will not depend on its concentration. It will be parallel to x-axis like this. Fine. So when AC is high, this will be parallel to x-axis. When AC is low, will be y equal to mx. Fine. So these we got when we combine these two conditions. Okay, this is a combined plot of Michaelis-Menten. Fine. Now coming to the Lineweaver-Burke plot. This is also a very important. Sometimes in the question you are given that in a Lineweaver-Burke plot we find got the slope is this, intercept is this. Like that way the question can ask. So you have to have the idea that in line Weaver bar plot, what versus what we are plotting, the x and y axis. If you have the idea, then you can solve any question. Okay, and you should have the idea of the how graphs are actually plotted by comparing with the which equations. So you have the you should have the a little bit knowledge of the graph plotting, then you can understood or you can solve any question from this. So in Michaelis-Menten plot, rate versus S we are plotting, rate versus S. Only this you have to know. Rest you can, after putting value, you can actually derive within, let's say, few minutes. Okay. So in line Weaver bar plot, we plot the 1 by R, means 1 by rate versus 1 by S. So we have to derive that also, right? So rate is, we know this. So if we take 1 by R here, this will be also reverse, like Km plus S by R max into S. And we can further this term can be actually this way. This will be equal to what? Km by R max into 1 by S is there. We can actually take this term as this and plus S into R max into S. Now S will be gone now, and it will be R max, sorry, Km by R max into 1 by S plus 1 by R max. 1 by R equal to. So we know now that we have to plot 1 by R versus 1 by S. This is 1 by R and this is 1 by S. Fine. So this will be compared to, this can be compared to y equal to mx plus c. Because x is 1 by S only and y is 1 by R. So rest will be slope and intercept. And intercept is always constant and we know R max value is constant. So here the, if we, if we want to plot this value, okay, so 1 by R is equal to Km by R max into 1 by S plus 1 by R max. Fine. So it can be compared with y equal to mx plus c, and which means this, because m is now, so slope will be, sorry, I am writing this. Slope will be here what? Km by R max, and intercept, the constant value, intercept will be 1 by R max. Okay. So plot will be a straight line with positive slope and intercept, positive intercept. Okay. This will be the now the line. So we have to have the idea that in line Weaver bar plot, what versus what is actually plotted, and when we plot this, after this we have to derive this within 1 minute we can do that, and we have to know that from this what will be the slope and intercept, because questions are asked from this straightforward, that slope and intercept value, or it can be in the question it is given, let's say, and some values are not given, you have to find that out. Like that way questions are asked. So that's why I am telling again and again. Okay. Now ED-Hofstee plot. This is third, not two. Third plot. Okay. 3 plots are there. You have to again know that what versus what. So R by S versus R. Rate by S, substrate. Okay. Rate by substrate versus R. Again, we have to derive. Now what we can do? We can take R by S we have to take, right? So R is here, and I am taking S here. Okay. So what will be it now? R max by Km into S, Km plus S, right? But we have to put R by S versus R. So here no R value is there, right? No R value we can see here, this side, so that we can compare with any plots y equal to mx or y equal to mx plus c. Nothing we can do here. So just multiply these two. Okay. After the multiplication, R by S into Km plus S, right? And R max into S. This will be the equation. Sorry. Only this is actually multiplied. So this will be not here. Fine. This is there. So it will be, okay, let's say I am multiplying only simply into Km plus, if we cut this S, it will be only R and it is equal to R max. Fine. We have to plot what? R by S versus R. Okay. So R by S is here. Uh, we have to place this term here. So R by S into Km, let's say, equal to R max minus R, and we are dividing Km here in the right hand side. R by S will be equal to now minus 1 by Km into R plus, this is R max by, we are dividing Km right now, Km. Okay. So here you can see this is R by S and R. Okay. So this is Y, this is X. Now it will be equal to, it can be compared with Y equal to mx plus c. Intercept is positive, but here slope is negative. If you see this slope, minus 1 by Km. So the plot will be now this one. It has a positive slope, will be R by S. Okay. And R by S versus R. And it will be, slope will be negative. Slope is negative slope. This one is slope. So will be minus 1 by Km, and intercept will be constant value R max by Km. So again, you have the idea about that. In ED Hosty plot, what versus what is actually plotted, and we can derive it easily. But if you can remember it, please try to remember it. If you cannot, don't worry, just derive it. Okay. For my case, I am actually, I just remember this one, what versus what is plotted, and I am deriving it. Okay. So that the error can be less, because sometimes if the negative sign, if you cannot remember, that negative sign was there, only 1 by Km if you put in the for the case of slope, the answer can be different. Obviously different, not can be. Answer will be different and your answer will be wrong. So to avoid that, I think it will be easy that to derive till this and then find out what is the slope and what will be the intercept. Fine. Now coming to the question part. Okay. So everything we have understood in the theory portion. What is actually the turnover number? Okay. What versus what are plotted? Okay. Three kind of plot we have seen. Okay. First we have seen the R value. I am writing here only. R value is equal to this. You have to remember R max into S by Km plus S, where Km equal to what? K inverse plus K2 by K1, and R max equal to K2 into E0. Fine. And what we know, the turnover number is equal to K2, and catalytic efficiency equal to K2 by K. Okay, and for the rest part, so what was there? The Michaelis-Menten plot, R versus S was plotted. Yes, and we have taken the two cases where S is very low, S is very high. Okay, so that is fine with the first plot, Lineweaver-Burke plot. Okay, second one was, sorry, it was Michaelis-Menten. Yes, Michaelis-Menten plot, plot, and Lineweaver-Burke plot. What versus what? 1 by R versus 1 by S. And third one is ED-Hofstee plot. ED-Hofstee plot, where R by S versus R is plotted. So these things you have to remember from this topic so that you can answer everything. So in this first question, this is from CSI and NET June 2018. So this is the enzyme substrate reaction. It is given again the same thing, E plus S giving ES and ES giving now E and P. Okay. The slope and the intercept of the plot between 1 by R versus 1 by S. What plot this is? This is the Lineweaver-Burke plot. This one, right? So in the Lineweaver-Burke plot, we know that this is plotted. So 1 by R is given. The slope and intercepts are given. I have told you now these kind of questions are asked. So we know R equal to R max into S by Km plus S. Okay. So 1 by R if we take, this will be Km by R max into 1 by S plus, if we divide this one with this one, will be equal to R max, 1 by R max. So this will be the intercept and this will be the slope, right? See in the previous slide, in the case of Lineweaver-Burke plot, slope was this one, Km by R max, and intercept was 1 by R max. Fine. So we have got that only within few seconds. Km by R max. Yes, Km by R max was there and 1 by R max was the intercept. So now we can equalize these two, this one, Km by R max with the slope value, what is given here, 10 to the power minus 1 second, and 1 by R max is given, means the intercept. Here, intercept is given 10 to the power 2. 10 to the power 2. Okay, and this unit is this one. Fine, the unit of K2 actually. Okay, this is forgettable. So here E0 value is also given. Why? What we have to actually find out? The value of K1. We have to find out K1 value. Fine. So from here, if we see, okay, these actually I am removing because I need a more space, bigger space. So these I am removing from here. Fine. Okay. So from here, what I can write, 1 by R max value is given, so I can find out the Km value because 1 by R max value is 10 to the power 2 equal to 10 to the power minus 1. So Km value will be this by this, so 10 to the power minus 3 will be the Km value. This is the Km value. Now we should have the K1 value here. Okay, K1. So we know that Km is equal to K inverse plus K2 by K1. Okay, Km value we know. So we have to find out the other values. This actually the question asked this and this value we need K inverse and K2. How we can get that values? Let's see. So it is given that E0 value is given. So we know that R max, everything is needed. See, R max value we know that K2 into E0, right? So 1 by R value is given, right? Because it is the intercept. So 1 by R value is, R max value is, let's say I am putting R max value here. 1 by R max value is what? This one? 100 or 10 to the power 2. So K2 will be, K2 value will be 1 by E0 into 10 to the power square, right? This will be the K2 value. So E0 value is what? What is given here? E0, if you see that here, so I am writing here, if you can't see this, 10 to the power minus 6 molar, right? So if we put the value K2 and 1 by 10 to the power minus 6 into 10 to the power square, it will be equal to 10 to the power 4. So I am writing here K2 equal to 10 to the power 4. This value also we got. Fine. So now what we need? I think one slide is needed. I will add one slide here. Okay. So we know the K2 value. K2 value is 10 to the power 4. 10 to the power 4. Km value is 10 to the power minus 3. 10 to the power minus 3. Okay. And K inverse value we have to find out. Right? So for the K inverse, what we get actually, what values are again given? K inverse by K2 value is given. Wow. Now we can have the all term values, the values of all terms. Okay. So K inverse by K2 is given. What value this is? K inverse by K2, this is 1000. 1000. So this is 1000. And for the Km value, we need K2 plus K inverse by K1. And K1 value we have to find out. Right? So K2 we know 10 to the power 4. So K inverse will be 10 to the power 4 into 10 to the power 3 will be equal to 10 to the power 7. So now we know K inverse value also. This is 10 to the power 7. These three we know. Now if we put in the Km equation, it will be Km equal to 10 to the power minus 3 equal to 10 to the power 7 plus 10 to the power 4 by K1. So K1 will be approximately, I am taking, okay, because we have to see the options. So this is 11 10 to the power 11 by 10 to the power 3. Oh, sorry. This is not multiplication, right? So for, sorry, my mistake. For multiplication, let's say a to the power x and a to the power y is given. Multiplication. For multiplication, we can write x plus y. But when this is given a to the power x by a to the power y, we have to just add it. Okay, we can't add the power. So I have made a mistake here. 10 to the power 11 will be not there. So as 10 to the power 7 value, sorry, I'm writing here. As it 10 to the power 7 value is very high than 10 to the power 5, 10 to the power 7 plus 10 to the power 4, we can assume it will be equal to 10 to the power 7. We can take that. So it will be 10 to the power 7 by 10 to the power minus 3. It will be equal to, or it will be close to, sorry, game was 10 to the power 4 minus 4. Okay, this is 2, 10 to the power minus 2. See, the quality is very bad here. So 10 to the power minus 2 was there. I have in my copy the same question. So that's why I can write it. Okay, correct it. So it was 10 to the power minus 4. So 10 to the power minus 4 means this will be 10 to the power minus 4. Aim value is 10 to the power minus 4. So this minus 4 will be there and 10 to the power 11 will be the answer. So in the question, see, 1 into 10 to the power 11, 1. The option number 1 will be correct. Fine, we have understood this. This was a long, actually, the long kind of problem, but this is easy if you know the all terms. Okay. So now the slope and intercept obtained from 1 by r against 1 by s. Again, 1 by r versus 1 by s. Fine. The enzyme catalyzed reaction, the slopes and intercept are given. So Michaelis Menten constant we have to find out. Km value we have to find out. So this is again the this plot, line Weaver bar plot, where slope is Km by R max and intercept is 1 by R max. We have just now we have done this, right? Km by R max and 1 by R max, line Weaver bar plot. So just Km by R max, this slope will be equal to the 300 and 1 by R max will be equal to 2 into 10 to the power 5. Fine. We have to have the answer, or we have to find out the value of Km. This is very simple. Okay, within few seconds you can do this, because 1 by R max value if you put here, it will give you the Km value obviously after the multiplication. So 1 by R max value is 2 into 10 to the power 5 will be equal to 300. So Km value will be 300 by 2 into 10 to the power 5. So it will be go to the upside and 10 to the power minus 5 will be there. So it is 150, right? So answer will be 150 into 10 to the power minus 5. But in the answer you have you cannot find out that answer, because you have to just modify the negative the 10 to the power term. Okay. So if we take 1 by 1.5, because in the answer 2 of the 3 and 4 options 1.5 is given, 1.5 into what will be then? We took this, right? 1 to 2 power negative power of 10, we have taken this, so this will be equal to minus 3, right? This is simple, you can solve it. So this will be the answer, this one. So 4 is the answer, this is the correct answer. Okay, now go to the next. So see, this is also a CSI and net question. So I am now coming to another important question. This is also from CSI and net. So this is, with this we know, and K2 value is given, E0 is given, the magnitude of maximum velocity and turnover number we have to find out. Okay. Now, so nothing plot is given here. Okay. Just from the equation or the derivation, which we got actually the Rmax expression, from that only we can have the answer. Okay. So K2 is given, E0 is given, magnitude of maximum velocity. So we have compared previously, the rate is actually the velocity of the reaction, right? So the maximum velocity means maximum velocity means the R max, obviously the maximum rate. So R max value is given, but oh, this we have to find out, and we know it is equal to K2 into E0, right? So K2 value is also given, and K2 and E0 both are given. So we should only multiply these two. Very simple this is. So the first question is only the not difficult, I will say. It was a lengthiest. So R max will be equal to K2 into E0, 10 to the power minus 2. Okay. And the unit, if you want to know, so unit of K2 is given as second inverse. So second inverse into the unit of E0, which is mole into decimeter to the power minus 3. Okay. So it will be 3.42 into 10 to the power 2 mole decimeter to the power minus 3 and second inverse. This is the R max, and this is also the rate of reaction, the unit of rate of reaction. Okay. So in the options, if we check, in this one option only this value is given, and the unit is also the same. This will be the correct option, but let's just now solve the turnover number. Let's just have the value of the turnover number also. So we know turnover number is equal to K2. So the K2 value is given, so it will be only the turnover number. So simple. We doesn't have to derive much or solve much. This will be the answer. Fine. This was coming for 4 marks. This and the previous one also. But see how small time is actually needed for this solving of this kind of question. Okay. So now Vmax or Rmax, same. Velocity maximum velocity for the reaction, and the maximum rate for the reaction. So both are same. So Vmax can be compared with Rmax, and we know that it is equal to K2 into E0. Right? Okay. So this is given. Okay. Both values are given. So Rmax value is given as 2 into 10 to the power minus 3 mole, sorry, this is not mole, molarity. So second inverse. And Km value is given. Michael is maintained constant value. 1 into 10 to the power minus 6 molar. Okay, not mole, molar. Respectively, the rate of the reaction when the substrate concentration is this. So substrate concentration S value is given, which is 1 into 10 to the power minus 6 molar. This is given, and they want to know when this is the substrate concentration, the rate of reaction will be what. So we know that rate of reaction is R max into S and Km plus S. Okay, so we have to know the S concentration. So this part the values are given. So R max is 2 into 10 to the power minus 3. Okay, we have to find out the R value, and S value also we know is given 10 to the power minus 6, and Km value is 1 into 10 to the power minus 6, and S value is also 1 into 10 to the power minus 6. So these are the same, right? So we just can write it 2 into 10 to the power minus 3. Here you can see. I'm writing here. So it will be equal to 2 into 10 to the power minus 3 into 10 to the power minus 6 and 2 into 10 to the power minus 6. So it will be only 10 to the power minus 3. See, this is also very simple. So if you see the options, in this option 1 into 10 to the power minus 3, second inverse. In all options second inverse is given. So we should not actually worry that much. So this will be the answer. Okay. If you want to know about the unit, you should actually write the units of all portion, and then you can find out. See, I am solving here. So molar, this will be molar also. This km value is km unit of km is molar again, and it is also molar. So molar will be cut down and meet sorry, this is the mole per second. This is also mole. This is sorry, RMS value is mole per second, and this is km is mole. This is also mole, right? So this below part will be mole, and in the upper part there is mole per second into mole. Okay, it should be mole per second actually, because the rate of the reaction they want to know. Mole, substrate is also mole. This is not multiplied, right? So we have to take the unit mole only. And Rmax is mole per second, and it is also mole. So mole will be okay. This will be mole per second actually. So just not worry that much, because in all options the unit is same. So you should not actually worry about the unit. Okay, we found the value. So this is all. So these are the actually the important equations I have incorporated. So you have just understood this. Uh, so thank you so much. So I have shown you the all types of questions which are asked from this enzyme catalyst reaction, and I hope you have understood this topic very much and you have found it interesting. And see you in the next video then. And thank you so much for your time.